question where we're looking at a parabolic bridge, which is 50 meters wide, and the height 10 meters from the outside of an edge, either edge, is going to be 12 meters. So what does this look like? I'm just going to draw a rough sketch here. So here's my ground, my x-axis, and I'm going to put a y-axis over here. Let me just lock that into place. And then I have my bridge, parabolic, which I'll put just like that. Maybe move it over a little bit. That's okay. So I know it's 50 meters wide, so that means from one end to the other, it's going to be 50. And because I'm kind of centering it around 0, I'm going to have a negative 25 on this end and 25 on this end. And I know that 10 meters from the outside, 12 meters from the outside edge, it is 10 meters high. So let's say 12 meters back from 25 is going to bring me to 13. And the height at that point is going to be 10 meters. So this here is 12 meters, and it's a height of 10 meters, 12 meters in from the end. And the same applies, by the way, to this part too. So if I have negative 13, again, this representing a distance of 12 meters, I'm going to have a height of 10 as well. Again, this picture is obviously very wrong, but the idea should be pretty straightforward. Again, these are on the same plane, the same horizontal plane. If you really want to see that, I'll make sure that they're both on the same plane. Okay, so there is our picture, our diagram. What do we want to do? So we want to find the maximum height of the bridge here in part A. The maximum height. In other words, we want to find the vertex. Now, to get that vertex, I'm going to need an equation. So that'll be my first item to accomplish, is to find an equation. So this will part A. I'm going to find an equation that models the bridge. So the form of this parabolic archway, parabolic bridge, I'm going to write it in a vertex form, where R and S are going to be my roots. And in this case, because I end up at positive and negative 25, my roots are going to be plus 25 and negative 25. Again, looking at our picture here, we have negative 25 as one root, positive 25 as the other. Fits nicely into our equation for factored form. But it still remains to be found is, what is the value of A? And that is where I'm going to be using this point over here, which in coordinate form is going to be 13, 10. I could also use, if I wanted to, negative 13, 10, which is this guy over here, but I'm going to just stick to my positive values. So I'm going to use the 13 and 10 to find the value of A by substituting. So let me just write that here, 13, 10. 13 for x and 10 for y. So I have 10 equals A, 13 minus 25, 13 plus 25, I get 10 equals A, 13 minus 12 and 25 is going to be negative 12. 13 plus 25 will give me 38. And if I crunch those numbers, I get negative 456. 456a, and therefore a is going to be negative 10 over 456, or if we reduce that, it'll be negative, divide both by 2, 5 over 228. Or if we want to make this as a decimal, it'll be negative 0.021. Again, go as far as you like. Personally, I like to leave it in fraction form. It's the more exact. Remember, here you are rounding, and if we want to be accurate, this is really an approximation of this fraction here. Anyway, we do have our equation now. To save some time, I'm just going to take this, paste it here, and kind of squeeze in that value for a that we just figured out, and that is this guy over here. So I'm going to copy that, paste it here, remove these highlights, and put it in. And there we have our equation, which now allows us to get our maximum height, the guy up here. All I have to do is plug in the value of 0 for x into my equation, and I'm going to get the value of the vertex, or the maximum. So what do we get? Well, y equals negative 5 over 228, 0 minus 25, 0 plus 25, and that'll give us 625 times negative 5. Notice I'm just doing a whole bunch of calculation at once. So 625 times 5 divided by 228. I end up with 13.7 meters. So that's our vertex. Determine the height of the bridge 15 meters from the outside edge. So 15 meters from the outside edge, if I go to my picture here, that'll be 15 meters. So I'm going in 15. So 15 subtracted from 25, that'll bring me to 10. And if I trace this up, I want to be somewhere here. So somewhere between 10 and 13.7. So let's plug in that 10 value into our equation and see what we get. So I'm going to copy this, paste it here, and for b, I'm going to use the x value of 10. Let's see what I get. Y equals negative 5 over 228. I get 10 minus 25, 10 plus 25. And what does this give us? This will give me negative 15, 35, which gives me negative 5 times 525 over 228, which is approximately 11.5. 5.1, or just say 11.5. And that is a reasonable answer, because again, if I look at my bridge here, this is a height of 10. We know the max is going to be at a height of 13.7. Oops. That's going to be at a height of 13.7. This is 10. And this point here, what do we say? 11.5. Which again is a nice, reasonable number right in between those two ends there. Last part, how wide is the bridge 4 meters from the top? Okay, 4 meters from the top. Well, what does that mean? 4 meters from the top. Let's erase some stuff here, clean up our picture. Okay, I'm going to take this guy out, this guy, this here, take these lines out. Okay, let's put in one value here. This topmost point, let me flatten that out. So this guy right up here is going to be 13.7. So 4 meters from the top is basically subtracting 4 from 13.7, which is going to give us 9.7. So roughly around, let's see here. So this is a height of 4 meters from the top. So that's the top. That's 4 meters from the top. And if you look in, it'll happen over here. Oops. And over here. Right there. And the question is, how wide is it at this point? So how far am I going to go from here all the way to here? Or, in terms of numbers, if I can figure out what this number is, let me get this guy out of the way, and if I can figure out what this number is, and I'll get this out of the way as well, right? How far is this across? Now again, the parabola is symmetric. So if I know this is, I'm just making this up right now. Suppose I know this is 7. Well, this has to be -7 because these 2 points are on the same horizontal plane. And the answer to the question would be, well, it's 14 meters wide, 4 meters from the top. Now, again, I made these up. I don't know what these are, but I'm going to find out. So what I have to find is what values of x, right? x1 here, x2 here. What values of x will give me this height of 9.7? And what I got to do is go back to my equation, which is this guy. And for y, I'm going to plug in the value of 9.7. So let's just get some real estate around here. Paste my equation, and I'm going to use a y value of 9.7. So let's plug that in, see what happens. You know what? Let me just take this part here, and I'm going to make it equal to 9.7. Now we got to solve for x, and I'm going to take a few shortcuts here because I can see them. If you notice, these two guys here is basically a factored version of a difference of squares, right? X squared minus 25 squared is equal to all of this business here, which is just x squared minus 625. And if I multiply in this value, I'm going to get -5 over 228 x squared plus 625 times 5 divided by, right, that's just 13.7. And I got 9.7 here. So I'm going to start the process of isolating for x by bringing this 13.7 over. So 9.7 subtracted 13.7, that'll give me my 4 negative, and I still have all this stuff here on the right hand side. And now I'm going to rid myself of this fraction by multiplying the left hand side by the reciprocal, and I end up with x squared times 4 divided by 5, 182.4 is going to give me my value for x squared. Again, I just did all this stuff at once. Final step, I'm going to take the square root of that, which gives me 13.5. And that's going to give me my x. Again, it's plus or minus because we have a positive and a negative value that will give us that. And if I go back to my picture, so that's 13.5. So 13.5 is going to be over here and over here, negative. And therefore, the distance across will just be 13.5 times 2, which is just 27 meters. And there you have it. We have a 3-step word problem here using parabolic bridges, archways, whatever you want to call them.